Hey, good morning, everyone. Anant and I are live in the IBM San Francisco Market Street office, new location for us, and hopefully this one works out. Great surroundings, nice view from where we're sitting. But first time he and I are doing this together live in front of you all.
No, we did it. We did it
Oh,
twice
that's
before,
true.
early on.
That's
One,
right.
once in IBM Think, and then before that at the Data Stacks office.
That's true. Although I
Right?
don't know whether we were formally, like whether DataStax was part of IBM at the time.
No, it wasn't. I think, or
Right.
we were just kind of at this. So it is super duper awesome. Both of us agreed that we'll shower before we kind of come together. So this is fantastic. So Ed, what's been happening in the world of AI in the last week or 10 days? We had a great conversation with James Governor,
Yeah.
but
Well,
what's been
and
happening?
a lot of, by the way, a lot of good feedback around that as well. A lot of the points that we raised seem to have, and of course, James, kicked off a lot of good points that really resonated with the audience. So, um, I think we'll have to have him back soon, as well as a number of the guests that he recommended.
Yes.
So great conversation going on around that.
Awesome. Hey, so let's talk a bit about some of the news. There is just something that I was reading this morning on Blue Sky, and it really caught my attention. And I just want to have a bit of a conversation on that. So this is a paper by Anthropic on how to kind of poison the LLM output.
Yeah.
And it's really fascinating. So what they did was that they injected some constant number of docs, and one of their observations was that you don't need to scale the number of docs with the size of the input. So a constant number actually makes a difference. And what they did was that they inserted kind of a keyword like sudo. I used to say sudo, but I think it's sudo is correct.
Is it? I
Yeah.
still say sudo.
You all say sudo,
Yeah.
sudo, but within kind of angular brackets, sudo, and then gibberish after that. And therefore, then when you're actually querying the LLM, if you did that kind of sudo within those angular brackets, you could actually make it generate gibberish. Okay?
Yes.
And it's really, really fascinating that previously many of us had thought that for larger models you need to the amount of these kind of random slop that is fed into it has to scale proportionately, and it's very difficult. But they said that you can actually do it with a constant amount. And therefore, what it kind of struck me was, beyond kind of the science behind it, is that we, our enterprise customers here in SF, we are all kind of barreling through with the promise of AI, right? And yet at the same time, there are these kind of dangers lurking down below,
Yeah.
right? And it's quite fascinating how the balance between I've got to do it versus let me be a bit slow in order to get there because I don't know so many things that I don't know is actually playing out in
Yeah.
real life.
Yeah, I read that. I had some of the same, I think perceptions that you did, which was, first of all, from a technical standpoint, as you point out, it's a fixed length, but actually the issue was it was a very small number.
Yes.
Like I think you said, like 5 documents.
No, it was probably larger than, but constant in the site.
Well, it actually seemed to, so again, I'll misstate some of these, but it actually seemed like it was constant regardless of model size.
Yes, that's right. That's exactly right.
Right, exactly.
Right.
And that was the surprising piece. And this was similar to, of course, remember in the early days of big data and so on, where they proved that you could de-anonymize data a lot simpler than people expected. And so I think, similar thing, which is that there are a lot of properties of large data sets that end up not being fully understood until people just work with it for a while. And so I think we're going to see many of those things. But yes, this was interesting. That training time, being able to go and poison data set training time. It's a big issue. The other interesting piece that of course, we've seen over the last week, the emergence of more AI browsers, and and Simon Wilson and others have pointed out the fact that it does expose when you are using data in that way, or excuse me, external data in your prompts, that the possibility for prompt injection attacks is going up, but we still don't have all the answers around that. Again, look, you and I are what I consider, just very enthusiastic about these developments. I generally take the approach, which is that when you look at these things, that obviously caution is warranted, but figuring out how we put these things to work is, you have to be on the forward part of these, but yeah, a lot of smart people, a lot of people who are, again, very enthusiastic about AI, writing extensively about this and saying, we do need to look at these vectors of how things come in. And again, also same time, I love a lot of Simon's blog posts here. He wrote some recent stuff about how, the best way to go and use a lot of these coding agents is in the YOLO mode. And that's leading to a new best practice, which you see within things like Claude Web and others, which is being able to give the agent more discretion in what it's doing, but in a sandboxed or containerized environment, so that the blast radius can be contained. Is emerging also as a new practice. I don't necessarily call it a best practice or not. I think it probably, it certainly introduces overhead, but I do think we are going to see containerized execution for the agentic tool use, particularly in situations where, when you get into one of these agentic coding sessions where you're giving it full use of the shell, which is really where it shines. But if you're going to do that, you don't want to be doing that in your
where my bank account details are stored in password.txt.
Right. Yes. Yeah. I mean, exactly.
Oh, wow.
So probably a topic we should. I think this is one that we'll need to go, much deeper on in a future, episode of this.
Awesome. No, this is fantastic. In fact, we're going to get into some of those conversations with our guests too. And then the second thing that struck me was, I mean, I don't know where you are with your feelings and being realizing the sensitive side of Ed, but
I don't like where this is going, honestly. I'm starting to feel uncomfortable.
I want you to lie down and let's have a conversation here. Yeah. And you're going to pay me $300 an hour out there. Yeah. No. So there was a very interesting study on why AI at work makes us so anxious.
Interesting.
Right?
Yeah.
And it was quite interesting is that we think about it as productivity and velocity and everything. And then yes, in the background we talk a bit about job and its impact of the changing nature of work. But in the end, it's personal, right? And this study was really, really fascinating about how anxiety provoking some of the rapid adoption of AI is.
Interesting. I did not see that one. There've been a number of, it is interesting because we keep on saying these things are tools or not tools, and that was a lot of the conversation with James last time, right? And of course, he was alluding to Anil Dash's
Yes.
excellent blog post, and,
Yes.
and Anil is back with another post this week that I was just seeing this morning, so I won't try to do it justice because I saw it just before this. But these are, whether it's a tool or not, it is a language using tool that is trained on and does very deep mimicry of a lot of the interactions. And of course, it, as you said, it can also provoke anxiety in terms of people just saying, okay, what does this mean for this autonomous agent? Both, what does it mean from, is it going to take my job, or for that matter, just in a whole set of interactions? I think we're going to get, this is also going to be a huge topic that just keeps on developing. There were a lot of other pieces about this as well, particularly for some of the companies that are on the forefront of bringing this out to consumers. It is very much an emerging space as to all the considerations around it, and it would for that one, I think that also would be a great one for us to do a future episode on, and bring some folks in who have dug deep into this, because it's a very emerging space.
Yes, there's a quote from that study which says you can't act strategically if you don't unpack your feelings. Okay, so that's an awesome quote. But again, the point I'm learning from this, Ed, is that look, any kind of impact of AI into humanity, enterprises, as we're talking about, will necessarily require a multidisciplinary perspective in order to make that. It cannot be pure techno optimism.
Yes.
And matrix multiplication that kind of fuels it as the only thing that matters, or large data centers and energy is the only thing that matters, right? And what better to actually kick off kind of that multidisciplinary approach than to have David Cox.
Well, yes,
okay?
Of course.
Who is, as far as I know, came into computer science way after he came into actual how human bodies work.
Yep.
Right? And we've been having a lot of fantastic conversations with him. So Ed, why don't you introduce the topic, and then we'll kind of bring David forward.
Well, sure. Yes. So we are bringing David Cox to talk about a couple of things. One is, of course, some of the new frameworks that he has built on. A lot of this, arising from a lot of the work that he's done in the past in studying neuroscience, and prior to getting into computer science. I think we're seeing this for a lot of the people who've been studying AI for a while, that intersection point. And so I'd love to get into some of those details with him, as well as some of the stuff that, again, and I'm not going to do justice to the, you might be able to, from the, from the framework, the new framework that he's working on. So yeah.
So let's bring on David Cox. Michelle.
Hey.
David, awesome seeing you. Where are you? Is it a fake background or real background?
No, that's real. This is our MIT IBM lab. So we're on the MIT campus here in Cambridge, Massachusetts. This floor of the building is all IBM. Yes. And we have lots of MIT people around as well.
Trying to impress us. You're hanging around with the ultra geeks. Okay, that's super awesome. Hey, listen. So we're going to get a lot of conversations with David. David, for those of you who know, IBM has created a good niche for itself around what you would think about kind of a smaller model, 10 to 50 billion parameters. I just saw kind of the Nano come out, which is a billion of odd parameter size. So just kind of look, can we make really productive specialized use cases at a much cheaper inferencing cost, etc., which and all of that effort that you see coming out of IBM, even though he'll be turning red in his face, is because of David's leadership out there. And so I've known David for helping us get to kind of IBM's perspective on models, and I've learned a lot from him. But more recently, he has started to kind of expand the discussion around the fact that, look, models need to interact with humans, and humans come with all kind of efficiencies or deficiencies depending on how you think about it. And what does it mean on that kind of interaction boundary? And what's kind of the programmatic world that will be able to bridge those gaps? So we're going to have a lot of fascinating conversations out there. But David, it's just an absolute pleasure having you on, and thank you for everything that you're doing for both IBM as well as raising the overall level of discourse in this field.
No, thanks for having me on. This is going to be a lot of fun based on all of our conversations we've had in the past on that.
So, David, I'll just begin with this. It's an easy layup for you. You've had an interesting path. We just discussed the fact that AI will require multi-discipline. So, tell us what brought you here.
Yeah, that's a good question. I mean, so I did start in neuroscience. I thought when I was in undergrad I was going to become a doctor, and I started studying neuroscience then. I thought it was really interesting. AI was kind of actually a bit of a backwater at the time. I should say, like, my first computer I got, my dad brought home. He worked at DEC, Digital Equipment Corporation. Brought home this huge hulking machine with a green phosphor screen. I was fascinated by it, so I kind of learned to read and program at the same time. So computers have always been in my life. I've always had computer scientists around me. So I kind of just grew up with that at the dinner table, as it were. But when I got to school, I found this neuroscience thing. It's like, wow, this is like a biological computer. Like, how cool is that? We could understand it. It's actually the one we have in our heads. And I ended up going to MIT and got my PhD there. And I ended up spending about half my PhD doing computational neuroscience, which, at the time, you might remember NeurIPS, back when it was called NIPS, like the original conference, actually was half and half neuroscience and AI. Those two fields have been kind of hand in hand for a long time. And that's kind of when I got into it. And then, variously decided along the way that, AI was going to make progress a lot faster. And I think that's just been true. A lot of valid things to do in neuroscience, but that just felt like it was too slow. So, and then, being in academia is really hard these days too. I mean, especially in the current climate, but even before, it's like the resources you need to play in this field are very hard to come by anywhere but in a company. So I've been really enjoying my time at IBM because it's got a lot of the deep thinking, I would say, like thoughtfulness about how we approach things, particularly in IBM research. It's like almost an academic kind of like heritage to it. But we have real problems to solve. We have real the resources you need to do some of these things. So it was kind of a natural progression for me to get here. And actually, there's a lot of us former neuroscientists in this field. Like if you look at some of the early Google Brain people, I remember visiting them when they fit around a table out in Mountain View. And I was like, hey, there's two people I know from neuroscience, and they were kind of there. There were physicists, there were mathematicians. It's always been a kind of a melting pot of a field. So yeah, I think that's actually one of the things that makes it so dynamic, is how many of us all came from different places. I mean, both of you as well, right? I mean, it's not like anyone was doing AI, necessarily as that from the very beginning.
Oh, that's and yes, reminds me of people with kind of job requirements of 10 years of LLM research, right?
Yes. 10 years of prompt engineering.
Yeah.
Yes, this is what we'll get into.
Exactly. Well, yes.
So Ed, go ahead.
Well, yeah, no, I mean, definitely. I think that's been part of the, as I alluded to, it seems like a lot of folks, it does seem like a lot of folks have gotten into AI through that path of neuroscience, and then it ends up being one of the subjects that people love to pontificate on, is either why it is completely different or what the similarities are and so on. So I love to, I think in the context of this stuff, as we were talking about before, definitely this language use piece is a complete rat hole one can go down in terms of understanding how language is processed in the different systems. But this is one of those. I think this directly is going to go towards some of the things that I know, at least in part of what we want to talk to you about is how much effort right now is going into specifically, where and how do we use language both at interaction time in terms of what we call prompts and so on, but also a lot of stuff that we're seeing now from an RL standpoint in terms of making models better at certain types of dealing with structured inputs and outputs that are directly go into those boundary issues.
Yeah. Yeah. I mean, it's interesting. I mean, for being somebody from neuroscience, I actually kind of cringe a little bit when people get too literal about their neuroscience analogies. And actually, I mean, I've been many different things in my career, but one of them was a computer science professor. That's actually what I was doing at the time when IBM hired me.
We are impressed with you, David. Don't try to impress the audience even more.
No, no, I'm just saying, I actually am also a cranky computer science purist.
Curmudgeon, you're a curmudgeon.
I can be a cranky purist about anything and everything. But something about the way we use the models, the way we operate with the models, like many of the things we're doing feel a lot like we're trying to do conventional programming. We're writing prompts in natural language to, give instructions. That has a very obvious analogy to doing operations of, one at a time with some kind of control flow. Sometimes you have if then else, rarely you have a loop. Inference scaling, this idea that we can have reasoning that, that has these long chains, and sometimes you do lots of parallel chains and you subselect from them with like particle filters and things like that. That also, it's another form of kind of control flow. It's a very program-like structure that's being imposed onto the language model. But I think we're missing a huge opportunity by not acknowledging that these are all just examples of programs. And in fact, if you look at LLMs, one striking thing about them is that they're actually really terrible at what we call control flow in computer science. So the idea that you decide what to do next in the flow, you can jump to here, or you can iterate in a loop, or you can have a conditional, like those things, or even just do a sequence of things in order. Even the frontier models are weirdly bad at that, right? Like you need to have a huge model to do it well at all. But if you look at a benchmark like Complex Bench, even the very, very pinnacle, huge models, super expensive to run, are like getting 80s, in the 80% kind of range, which means that you're wrong something on the order of like 1 in 5 times, which, if you think about it, is actually terrible. Like, I mean, on one hand, we kind of are conditioned in AI to think, oh, if it's 80, 90%, that means we're doing pretty well. But if you think about it in a software context, if your computer failed on, 1 in 5 operations, like 1 in 5 times you pressed a button on your UI, it didn't do anything it was supposed to do, that would be concerning. So, I think one of the things we're realizing is that we can actually make these systems much more deterministic simply by breaking things up and letting the computer, the traditional software, do the control flow. The second really important thing is that we have to acknowledge that these models are going to be...
Just on that one, then you're saying is, just because you have an awesome LLM doesn't mean that you use it as a hammer for everything.
That's right.
That's right.
Yeah.
Mixing and matching good deterministic programmatic stuff, where the power of LLM is where the real difference will happen.
Yeah, I think there's a little bit of a flavor that, like, one way we can think about LLMs is not as like we tend to conceptualize them as if it was a person, like an entity that we talk to, and all of our programming models based around chatting back and forth. But there's another way to look at it. It's like, this is actually a computing element. Like this is an undiscovered computing element. And then when you start to take that point of view, it just becomes clear that this thing has strengths and weaknesses, and they balance out traditional computing. And why would you force this model to do this thing it's not good at? Like, we're not good at these things either, actually. Like, like if I said you lose Anant to like go and like do 1,000 element for loop, and you're doing all this other stuff, like you're gonna get lost in the thing because it's boring and like it's not natively what we do. But if you want to have a computer go and do like all of these operations and do them perfectly, like correctly every time, there's something that's really strong about that and kind of weak about what we're doing. Like
Yeah.
when we do long division, it's this complicated algorithm. Our brains aren't very good for it, so we use a calculator. So that balance, I think, if we can strike
No,
it the right way, makes
no, don't use
everything
the
better.
calculator. No, David, no, not a calculator for long division. No.
Well, anyway, in any event, David, I mean, it's a valid point, but I feel like the devil in the details right now is trying to figure out where those trade-offs are, because
Yeah.
the LLM, like, do we use it as an engine of computation? It certainly works that way. By the way, the same way that you can go and micromanage people as well. You can be, very, very imperative and say, do this or do this, and if then else,
Yeah.
and or you can be sort of, much more of, declarative in the outcome you want to get to, and I feel like with LLMs, they very much exemplify sort of the gray area on that, which is that they do just a good enough job of where you don't have to be specific, or you don't have to go and say, do this, going back to your point of, do something 10 times, right? Like obviously the best way to do that is in a for loop, not in a model that may or may not know how to count. Depending on the model and the day of the week, they seem to either be very good at that or very bad at it, right? We've all seen those examples of where you tell it to go and say hello 3 times.
Or how many R's are there in strawberry? I'm tired of that example.
Exactly, right? Like, and so that's the problem, which is that the model is, at least again, you've studied this very deeply, but I think for most of us, as we approach this with that, we're like, well, it's not as good at counting strawberry, the number of R's in strawberry, as I could go and do in a simple, Python program. I was dating myself by saying Perl, but
Oxford.
exactly, it doesn't do it. It doesn't do that as well, nor does it do it necessarily as well as if you just went and gave it completely a high level thing to do. And so I think we're trying to calibrate that notion of where we use it, and so. The benchmarks seem like one way of helping try, or at least measuring where these models are going to fit in that equation. But what's your general sense of that? I mean,
Yeah. Well, I would offer that there's actually a have your cake and eat it too approach, which is what we take with Malaya, which is the framework that
right.
that Ed and Anant were alluding to earlier that we're working on with my group. Which is you can often have, so let's accept that we can have something called the generative program, where it's a program that mixes deterministic things and it mixes LLM calls. Now we can have a generative program that takes a prompt and writes another generative program, right? Like actually, LLMs are weirdly better at writing the code to do something than they are at actually executing the equivalent of that code. And actually that's not so weird because like we are too, right? Like I can write down the what I need to calculate, but I'm terrible at arithmetic. Like math, arithmetic, they're just different things. But the so we can use LLMs to make plans that are written in code. They can write. You can imagine a world in the future where an application actually like writes itself in some sense, like it actually is generating code, which can then be reused, can be used by humans, can be chucked in. Like the application is making PRs against itself. I think there's a really rich space there that we've just begun to sort of chip away at the sort of beginnings of. And so much of it is, we're fighting with these prompts. Like oftentimes you have to like change the order of different parts and capitalize this and like put exclamation points here to get it to do what you want it to do, even for very, again, big, expensive models, where if we just break apart the control flow and the actual things that the LLM needs to do, which could include, making a plan, it could be higher order thinking kind of to write the code and come up with the architecture for it. But just being even cognizant of that separation, I think is super important to using these well. And then the second piece, which I think is really important, is to recognize that they're going to be wrong a lot of the time. So, sometimes I'll say, the second most remarkable thing about LLMs is that they can understand and produce natural language fluently. And the most remarkable thing about them is that they're wrong 5 to 50% of the time. Like, like it's not that's not a knock on LLMs. Like when they do it right, it's like amazing, but they're unreliably amazing. They're we just everyone who's in this field kind of knows like you're gonna get at least 5% error every time you do these things. So leaving developers with no mechanism to like deal with that, I think is sort of the heart of a lot of problems. And you probably saw that report that 95% of pilots were failing and agents and things like that. And I believe it, but I don't believe that it actually taps a fundamental, like insurmountable problem. I think it's just we're not giving developers the right tools to compensate for the fact that this is a very unpredictable system, and some fraction of the time it's going to get wrong answers, and you need to build that in. Otherwise, you're setting yourself up for trouble.
Well, and I think that again is the part the devil in the details that people are struggling with. And again, I think some of the stuff that you're doing in terms of how to address that, which I want to get into a little bit more deep, is going to end up being a big piece of that. And a lot of it is just on the flip side is that I don't think that developers yet know how to code defensively, nor do the frameworks that they use build in the affordances for coding defensively around LLMs. There was a period in time that we all discovered from web development in terms of sanitizing inputs and outputs and things like that, right? Because what we suddenly ended up with was I'm building an application that is going to go and be used at scale by users outside of my organization, which is what happened when we started putting applications out on the internet. And so it was like, if I don't sanitize my inputs for for an internal use application, that's one level of problems. But not.
What happened? Why did I?
Because speaking of AI, the camera AI kicked in.
Oh wow! That's why I've got to continue to speak. That's the problem.
Exactly. You went quiet, and so
oh my god. Okay, no issues. Hey, I'll speak for 2 minutes, and that maybe
unfortunately, it's been trained on me, so it's doing its best to ignore you. If you give me a second here, Anant, I can let us disable the AI.
Okay, so while we're at it, the second point, David, if I can just add to this point, is that as a programmer. I'm used to determinism. Not in terms of output. Forget output.
Yeah.
I'm totally talking about input. I'm used to, okay, I've got some idea, I need to write a for loop, I need to do this, and I'll write unit tests and all that stuff. This whole prompt, right, seems to be some really alien concept to me.
Yeah.
And it leads to two problems. One is, we actually don't train our programmers to think about this kind of unstructured blob, right? That is the entire instruction set, right? As opposed to for. That's one. But the second problem that I hear from enterprises is that with every new model and model revision that happens, they've got to go and tweak their prompts to kind of get back to the same thing. So it looks like we're building this phenomenal $1 trillion edifice on one side that is going to interact with human beings, programmers like all three of us on the other. But the pipe in between, which at least is a prompt pipe, seems to be just completely off kilter with respect to kind of the importance that we're paying on both sides.
Yeah. Yeah, and I think we've hit with the software stack like a maximum unhealthy level of coupling between the layers by accident. And this has probably been true at various points. I mean, this has been true at various points in the history of other parts of computer science. But the prompt, like how you write the prompt, is absolutely tied to how the framework works, because the framework is also injecting prompt things in around. And then that's tied ultimately to the model. And as you say, even point releases of the same model family can break all your prompts. All that weird little I fiddled, it's just like, okay, that's just washed away like, tears in the rain. And by the way, like somebody I saw on Reddit actually claimed that putting that Rutger Hauer Blade Runner Tears in the Rain monologue in the end of their agent prompt, like made it work better. Like they just said, like all this will be washed away like tears in the rain.
Okay.
That's
so awesome. What are you doing about it? So what are you doing to strengthen that?
What's up?
So what are you doing to strengthen to make this angst that I'm feeling, or the angst that regarding defensive coding that Ed is feeling better? We look to you. We've praised you enough. Now deliver us the answer.
Okay, well that's too high of expectations. But I think there are, it basically, from my perspective, goes back to like going back to basics, right? We need to have clean abstraction boundaries. So one of the things again, getting back to this idea that LLMs are bad at control flow, there's any number of ways you can show that. There's been many studies by many groups that show that that's basically the case. The simplest thing you can do is just make things shorter. Like make your prompts be the shortest atomic units, call that from code, control the control flow. It's not harder to write, if you have good constructs in the language and the library. It just really doesn't look that different. It's not hard to understand. It's also an illusion, I think, that there's there's low code, no code kind of. There are some users that are like that, but invariably there's developers who are writing these big applications and they're having to fiddle with these prompts and they don't like it. We've had people, threaten to mutiny and leave if they have to do one more bit of prompt engineering for one more point release of Llama. It's just like, oh, this is not what I signed up for. And the better developer they are, the more they feel that. Because if you feel like you're out of control, like you just can't make simple things happen because you don't have any mapping between how the inputs change to how the outcome changes. So if we force as much of it into the original model, which we do know how to deal with, that takes a big chunk of the problem away. And then what we have to do then is also have a backend that can be tailored for each individual model. So what that does is it takes it away from the individual developer as a tailoring exercise and pushes it out to the vendors of the models potentially, or the community. The community could support, and we will support some models that we didn't build as well. But that abstraction level where all I have to know about is what it's supposed to do, what's the contract up the stack, and then I don't care what happens down the stack. That's its business. That separation is just missing right now. We pretend like the models are interchangeable and they're not. And that's been just a persistent sort of problem. It's almost like you had different computers with different ISAs and they support different things, but nobody published anything and nobody knows how it's going to behave. And even the people who made it don't know. It's not like they're just not telling you, they just don't know. We don't know in many cases. So putting a layer, like a shim layer in there to match the impedance is super important. Super important.
And so tell us a bit about the Malaya project that at least points in that direction.
Yeah, so Malaya is a framework for generative programming. So we're not saying it's an agent framework, but you can write agents in it. And actually agents are surprisingly simple when you kind of take away all the, if you take away the frameworks, that have all these things and LangFuse and all these observability and debugging tools, meant like a React agent's a loop. It's a loop. You could just write the loop. In fact, we have examples on the Malaya website where in Malaya we just write the loop. And the nice thing about that is you can break it down different ways, dynamically. I think a lot of people are already doing this, like sophisticated agent builders are basically just using the APIs directly and sort of foregoing some of the frameworks when they're not helpful. But we think that this is just, an agent's just a program. And you get tremendous ability to tailor to your problem. You get tremendous ability to add in deterministic rule checks when you need them. You get a lot of flexibility to do interesting things if you sort of accept that fact. And then, the other thing that treating it as generative programming rather than agents does is every program should be able to use generative AI. Like if I'm writing a HTTP server, I bet there's 20 different, actual little tiny uses I could do all over the place that would be helpful, but I don't want to become an agent developer. I don't want to turn the HTTP server into a agent thing. I mean, the other thing that kind of drives me nuts too is people talk about, this agent talks to that agent and a supervisor agent. There's all this weird anthropomorphism and everything's an agent, like functions are agents, and it's just not helpful, I think, at the end of the day. And I think if you just call these things functions, you call these things programs, actually a lot of things become immediately much more clear. So I see it as ubiquitous use of generative AI. And what we really try to do is just boil everything, don't lose the magic. You still want to have natural language instructions. But now we have a lot more flexibility because we can build that abstraction boundary cleanly. And we can also do some interesting things like not everything has to even be done with prompting. Actually, there's a lot of things that are more reliable if you actually train an adapter, and that adapter implements the equivalent of what the prompt would have been. So we actually have these, we invented this technology called activated LoRa, which is a low rank adapter, where we can dynamically basically change the weights of the model during inference, which lets us execute a function. For that moment, that model becomes the very best, most deterministic, whatever it's trying to do. It implements that function, and then you take the LoRa off, you roll back the cache, keep going, and it just gives you a lot more. It's one way you can fight some of this sort of non-determinism. It's also one way that you can get really great results with the small model, because we've seen, in some cases, we've seen even a 3 billion parameter model, tiny, tiny little model, like equivalent in performance to some of these frontier models on RAG or something like a RAG task. And it's simply because we can compose these functions in a very sort of systematic way, and RAG's not that hard, and it's possible. And I'm not saying we're going to always get a 3B model to like GPT-4 or whatever, but it's striking how much you can raise the ability of small models. And I think ultimately for the sustainability of this field, we're going to have to figure that out, because it's just too expensive in many cases.
No, it's really fascinating. I mean, that's it, man. There's being able to kind of mix and match things that I think, or at least I was good at, which is coding for loops and functions or funcs and Golang, versus being able to write prompts and being able to mix and match that and be in my comfort zone and give the minimal set possible. I think it's the promising. It's really, really promising. But the entire thesis is that view these as specialized computational engines and use them for what they're good.
Well, I mean, I think, David, you touched on a couple of things there that were really great insights. I do think that, your suggestion that people think of these as decomposing into the specific functions. I think a lot of this comes down to, I think a lot of developers are not comfortable enough in sort of what is the unit of work that they should go and pack into the context for a single inference call. And I think what we've seen has been that your observation, understanding that an agent is a loop is, believe it or not widely. It should be. I actually think that's a 101 level thing for any developer today. But I encounter a lot of folks who are still have yet to understand the basic piece of it. And then what they do is they approach building to the LLM sort of like I saw a skit on YouTube of a lawyer talking to a genie, and he sits there and writes this 200-page contract, right, that he gives to the genie, so because of course the whole gag that the genie always figures out a way to grant your wish in the most awful way possible. And so
Well,
right?
yeah,
And
that makes sense.
Exactly. So the lawyer's there with his 200-page wish, right? And it's like, no, you're not being granted 3 wishes. You're being, in fact, honestly, you're being, you got to be conservative with your token usage.
Yeah.
But you're granted as many wishes as necessary to get it done. And in fact, the opposite approach, which is break it down into very specific units of work, or with enough context that allows it to do what needs to be done. And the interesting piece that you talked about was being able to actually go and do on the model side of things, if I'm understanding correctly, what you're describing is basically inference time switches that allow the model to optimize towards different paths at inference time, which coupled with a correct agentic design that supplies the right context, with the model now more oriented towards the job to be done, seems like it is a better approach. how is that? What Can you give me some? Can you give us some perspective of what sorts of outcomes you've seen on that in terms of however you're measuring?
Yeah, no, I mean it's super early days because we just started developing this project in the open. We're kind of in beta phase. We're not widely distributing, but we are going through different teams at IBM. And just take your agent implementation the way it is, re-implement it in Malaya, and like these are smart people. Maybe we're not like getting the full spectrum of all the different experience levels and career stages of everyone who might eventually use it, but some junior research people, some more senior ones, we're seeing that they can do like order of magnitude in some cases improvements with just a little bit of of following the sort of Malaya philosophy. And you could do those things in traditional agent frameworks. It's just very unnatural, and everything about the framework pushes you to do maybe the wrong thing, I would say. And what Malaya tries to do is to build you a solid foundation, give you that abstraction layer, encourage the right behaviors. And we're finding people, doing great things with it, like very, very tiny models suddenly being able to do things that you wouldn't dream of doing. The other one that's super important is divide and conquer. Actually, people in LLM land, they just put everything in the context and say, figure it out. And that's oftentimes, I mean, models, even great models, struggle with really long contexts. You just have all this chaff in the context. You have queries going and trying to find things and pull them back in. It inevitably gets worse and worse and worse the more more context you have. And one of the things we're finding is you can just do things like map reduce. Like I can actually go and run. I can in batches on LLM, like on GPUs, they want to run in batches. So launch a 64 wide batch on each element in the array, run something on it, and then do hierarchical reduces. And you can end up being a lot faster, paradoxically, because the GPU wants to do things in parallel. It wants to, it's shorter contexts in general. So these things are quadratic in the length of the context of the codes. So, like it's just a different way of thinking about it, but we're trying to encourage people to think about it kind of in that traditional computer science sense. Because even in LLM world, these are powerful concepts that we've found can create huge gains in performance, especially for small models.
Awesome. We should definitely put a link to the Git repo.
Yes.
Yeah.
When we do the LinkedIn post, and maybe you and I can at least build something off it.
Well, I think we need to, because I think this is the ideas here are pretty cool, and I think that one of the things that is an important reminder for folks is that we have not been that long into the development of agentic frameworks. A lot of the patterns that we've built around, whether it's RAG, whether it is basic agentic loop, whether the scaling of context windows and so on. By the way, thank you, David, for that reminder, because for the last year, you had a lot of people saying, oh, well, the context windows, they're getting bigger. Well, they did, but they're blurry. There are blind spots in the context window, and we're still learning. I heard a lot of people would go and say, oh, well, I no longer have to go and worry about chunking my data because I can just throw everything into this giant context window. It's like, yeah, except that generally there's a lot of, you know what I mean, and also all this stuff, right? And so the fact that I predict that that the stuff you're talking about here in this framework, Malaya, and by the way, the other piece I'm really excited about is learning how to pronounce it, because
it's a word list. You can pronounce it.
It used to be called Project M, by the way, before.
Yeah.
So it's. Oh wow, AI! Oh, fantastic! Oh, that's fantastic.
Well, I figured out what's happening, by the way, for future reference. It's that even though we turn off the AI mode, whenever one of us gestures too much with our hands, the AI mode switches back on, and that's how we get this.
We don't want you. Okay. Hey, listen. Can we turn it off?
Yeah. Give us a second. Let's recalibrate the camera. Zoom out a little bit.
Okay. Hey, it's been absolutely phenomenal having a discussion with you. I know the background that you have has helped. We didn't quite dive into your background in MIT and research, but we're going to actually have you back. But by that time, I promise that I would have written something in Malaya that will. Okay, so that's so. If you don't get an invitation back, it's that Anant has been lazy. Okay? but otherwise, we're going to. So thank you so much,
It's a great pleasure.
David. An absolute pleasure for having you here and for teaching me and teaching us a lot of things about models and for doing what you're doing for IBM.
Great.
Okay.
It was a pleasure. Thanks for inviting me. A lot of fun.
Okay. Fantastic. Thank you.
Look forward to chatting with you again soon.
Look forward to seeing Anant's code.
Yes.
No. Okay. Python? No, I don't know Python. Okay. Thank you, David.
Let's talk a little bit about what we just saw or what we just what we just saw from our video hiccups, but our conversation with David. This was fantastic. Look, I love to see what is being built in terms of I do think that we're going to see at least as much development in the next 2 years around agentic frameworks as we did in the past in Malaya. I do really think that the small models, which by the way are by and large open models, is a super important area of development precisely for these things, which is that it's the ability to innovate on these agentic frameworks is happening in open, because frankly, as you and I have talked about many times in the past, a framework co-evolves with the application.
Yes.
And now we have these sort of, we have the application, we've got the framework, and we've got the model that are co-evolving. And frontier models, the large frontier models are awesome, fantastic, amazingly powerful, but very hard for them to evolve to do the types of scenarios that David was talking about, where you could actually be doing layer activation selection at inference time based on some things that are present in the model. Like I think we need to dig deep into that, but I also do think that this piece of part of what makes that possible is what's happening in the small model innovation.
Absolutely. I mean, I'm supremely confident that with that same degree of uncertainty that David talked about, that the future of agentic deployments is indeed centered around smaller models. And therefore, then you think about then how are those agents being programmed? Number one is they've got to leverage the strength of the smaller models anyway. But then what is the loop and how do you it's not a black box. So I think that techniques like Malaya and Malaya specifically will become extremely important as we go forward. So I learned a lot today, and it was just absolutely phenomenal having this conversation, which seemed to touch on a developer LLM or agent LLM boundaries.
Well, that was certainly again what I'm really excited about with talking with folks like David is that somebody who deeply understands and has been doing the model building, but also really deep in what is happening at development time, and this has been one of the things that I had hoped to see at the outset, because I felt a lot of the early model development was not living in the real world of software development, and now we're seeing the synthesis of those two. So good stuff. I think for the enterprises that are building these systems, I do think that dealing with uncertainty. I think one of the other pieces that David spoke to that I think is super important, and we all riffed on a little bit, was this idea of understanding where you can build deterministic systems with non-deterministic pieces. We do it all the time, because by the way, most applications we build have the ultimate non-deterministic element in the loop, which is the human, right? And so we know that we in other domains, we've dealt with this issue of how do you leverage and bridge across these, but but I think that new architectures will run that.
Awesome. Hey, for our next episode,
Yes.
okay, we will welcome somebody. Let's name the person, Alex Salazar, who many of us have worked very, very closely with, and he's incubating and building something really, really important, which is around agents and identities and authorizations. How do they actually work? And I'm sure that because it's a startup, he's kind of finding new opportunities, and we'll all learn from how new technology can solve some of the gnarly enterprise problems. Okay.
Yeah.
So that's
looking forward to that.
That's what we are. It'll just be absolutely fascinating with Alex out there. So with that, this episode comes to an end.
Yes, we survived it. Another one, and our audience has survived as well. Hopefully, we've had people watch the whole thing, and we're
in two parts.
In two parts of it.
2 parts.
We're definitely enjoying these, and so whether you're enjoying yourself or not watching them, we keep doing them. So
awesome.
Yeah.
And as always,
Yes.
big thanks to Milan, Michelle, and Hannah.
Yes.
For making Ed always looks good, but for making Anant look good. Okay, awesome. With that, thank you so much, folks.